friends, this is Bhuvan, and in our last class we had discussed class 8 first chapter rational numbers, and in this class we'll again continue the chapter and we'll complete that chapter. And in last class we had discussed about what are the types of number systems such as natural numbers, whole numbers, integers, and rational numbers, which is our required. And the rational numbers we had seen. Rational numbers means it will be denoted in the form of p by q, such that p and q should be belongs to integers and natural numbers, and the q should not be equal to 0. And in last class, we had stopped till the properties of commutative, associative, distributive, and closure property. And today we'll start with the role of 0 and role of 1. So, in additive identity, we'll discuss about role of 0. So, what is 0? Generally, any number which is added with 0 will provide at the same result. Any number when added with 0 will provide the same result. Any number when added with 0 will provide the same result. So this is known as additive identity. So what is additive identity? Additive identity means 0. So 0 is the additive identity and it can be asked in 1 mark question. So multiplicative identity. Multiplicative identity will discuss of role of 1. Role of 1. So what is 1? Any number when multiplied with 1 will provide the same number. So addition. In addition with 0, same result. Multiplication with 1, same result. This is what we had based in our last class. And next we'll see about what is reciprocal, and after that how to represent rational numbers in number line. These two concepts are still pending. So we'll be seeing about reciprocal. Okay. Reciprocal. So what is reciprocal? Reciprocal means when a number, when a number, for example, let us take as x, when it is multiplied with its reciprocal, when it is multiplied with its reciprocal, it should provide the result as 1. That is the definition. In simply, we can represent it like this. Any number when multiplied with reciprocal will give the result as 1. For example, so 2. When multiplied it by 1 by 2, it result will give 1. Okay, 3. When multiplied it by 1 by 3, it will give result as 1. Then they might ask, what is the reciprocal of 2 by 3? Then what is the reciprocal? 2 by 3 into 3 by 2 will give it as 1. This is what reciprocal means. The reciprocality sign designs the whether when it is multiplied with the number, it should provide the result as 1. Okay. So these are the topics which we have to cover in our last class, and these two small topics were pending in the last class, and now we will be discussing few how to represent rational numbers in a number line. Okay, how to represent rational numbers in a number line. Okay, and from the last classes we had known how to represent values in number lines, whereas rational numbers. See, what is a number line? Number line is a representation of numbers. Representation of numbers. Okay. So what kind of number line is this? This kind of number line is known as natural numbers. Natural numbers. And then when the natural numbers are represented on number line, it's known as natural number line. When whole numbers are represented, whole number line. Rational numbers are represented, rational number line. Okay, this is how we have to represent natural numbers. If whole numbers means including 0. See, 0 is there, so whole numbers. Integers means negative numbers also. Rational numbers means fractionals. Fractions also will be represented. So, if they ask to represent, okay, 1 by 8, represent 1 by 8 in number line. How do we represent? So, I will tell you a small way to represent these values in number line. So, what is the required question? Represent 1 by 8. So, first step is to write 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. We have to write like this. And after this, we have to divide it by, what is here? The divided by 8. So divided by 8. 8, 8, 8, 8, 8. So now, where is 1 by 8? This represents the 1 by 8. This is the value of 1 by 8. So now, how to represent minus values? Let us take one more example and let us understand it. For example, minus 7 by 4. Minus values, let us start 0 from this side. 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Okay, so divided by the denominator. 4, 4, 4, 4. Now divided by 4 and represented. This is minus 7 by 4. Okay, as you hope, this is the way how to represent in a number line. Okay, how to represent in a number line? First write the natural number. First write if the value is positive, the rational number is positive. First write the numbers from 0 to some values and divide it by the denominator of the rational number and you can mark it. Okay, so now with the help of this, we can perform addition, subtraction, multiplication, division, and it is not necessary. The next topic is how to find the rational numbers between two integers, two rational numbers or two integers, etc. How to find the rational numbers between two rational numbers. Okay, so first we should determine. Okay, first we should determine how many rational numbers can be possible. So first, how many integers are possible between 2 and 3? See. How many natural numbers are possible? 0. Okay, if you take 4 and 7, how many natural numbers are possible? 5 and 6. Okay, so whole numbers are possible 5 and 6. Integers 5 and 6. But in case of rational number, it's not like that. The value is not definite. So let us take the example of 3 by 10 and 7 by 10. Okay. So if anybody asks, what are the rational numbers? Mostly the answers will be 4 by 10, 5 by 10, 6 by 10. So they will write the answer as 3 rational numbers, which is absolutely wrong. Okay, absolutely wrong. But you know that see, 3 by 10, 7 by 10. So when we multiply it by 10 by 10, when we multiply it by 10 by 10, same rational number only, 30 by 100, 70 by 100. Okay, now how many from 31 by 100 to 32 by 100? Okay, up to 69 by 100. These many rational numbers will be there. So the value is not definite. So again you can multiply it by 10 by 10. So the value increases on. So we should come the rational numbers is not defined. Means they are not definite. Infinite number of values will be there. Infinite number of rational numbers lies between two rational numbers. And after this, we have to see if they can ask questions like name a rational number. So write any three rational numbers between minus 2 to 0. Minus 2 to 0. So we can write minus 1 as one rational number. So minus 1 by 2, minus 1 by 3. We can write it like that. So these values will come in between minus 2 to 0. Okay. So some people they might be having confusions with rational numbers. So for them, I'll tell you a trick. So for example, let us take A and B are two rational numbers. Then to find a rational number between this, we have to find the mean of these values. A plus B by so A will be greater than or equal to B by 2 greater than or equal to B. So this is the formula or a trick to find the number of, not number of, a rational number, one rational number or two rational numbers between any two numbers. Okay, for example, let us take, how to find the rational numbers between two rational numbers by using the formula a is greater than a plus b by 2 greater than b by 2. This is how we find it. Okay, with the use of mean, with the idea of mean, we can find any number of rational numbers. So, if a and b are two rational numbers, then a plus b by 2 is also a rational number between a and b, such that a will be greater than or equal to a plus b by 2, greater than or equal to b. The next one, find the rational numbers. Okay, three rational numbers between 1 by 4 and 1 by 2. This is the question. So, some people, they will try to, two ways are there. So, one way is to make the denominators equal. So, multiply it by 2 by 2, multiply it by 4 by 4. Make the denominators equal. 2 by 8, 4 by 8. So, now 3 by 8, one value we got. Okay. So, now again multiply. We are not getting 3. So, again multiply by 2 by 2. So, 4 by 16, comma, 8 by 16. Now we'll get two values, 5 by 16, 6 by 16. So these three we can tell it as the rational numbers. But this is a confusing method to some of our friends. So now we can use the formula. So A is 1 by 4, B is 1 by 2. Then what is A plus B by 2? 1 by 4 plus 1 by 2 by 2. Take the LCM into 2 into 2 into 4 into 2. 2 plus 4 by 8. Okay. 2 plus 4 by 8 by 2. So 6 by 8 into 2. 3 by 8. We got the same value as before. So now again if you want to find another rational number, okay, again apply the formula between 1 by 4 and 3 by 8. Now, 1 by 4 plus 3 by 8 by 2. Find the LCM. 5 by 16. Same value. Again, you find the rational number between 1 by 2 and 3 by 8. 1 by 2 plus 3 by 8 by 2. Find the LCM. 7 by 16. So these are the rational numbers. And this is a simple method to find it. And it's an easy method also. So how to find? Let us take one more example for a proper clarity. Okay, we'll take one more example for a proper clarity. Okay, so write some three rational numbers again. Let us take four rational numbers between 2 by 5, 1 by 2. Okay, apply the formula. First case, a plus b by 2 minus 2 by 5 plus 1 by 2 by 2 into 2 into 2. 5 into 5. So, minus 4 plus 5 minus 1 by 10 by 2 minus 1 by 20. One rational number we found. And next, second case. Find the rational number between 2 by 5 and minus 1 by 10 minus 2 by 5 minus 1 by 10 by 2. Multiply it by 2. Minus 4 minus 1 by 10 into 2. Minus 5 by 20. One more rational number. Third one. Okay, between 1 by 2 and minus 1 by 20. 1 by 2 plus minus 1 by 20 by 2. Multiply it by 10. Okay, so 10 minus 1, 9. 9 by 2 into 20. 9 by 40 over. So these are the three rational numbers. So now with these topics, the chapter of rational number will end. So let us now repeat, or let us now revise what we have learned in this chapter. in this chapter, we had started with number systems, natural number system, whole number system, integer number system, rational number system. Rational we can represent it by Q. Okay, so natural numbers 1 to infinity, whole numbers 0 to infinity, integers minus infinity to infinity, rational numbers similar. So now we have to try to draw the diagram to represent these values. So these sets on relations we learn in class 10, on class 11, then you can understand it better. So let us represent natural numbers like this, whole numbers like this, integers like this, and rational numbers. This is the manner. This is the manner. Okay. So all natural numbers are rational numbers. All whole numbers are rational numbers. All integers are rational numbers. But all rational numbers are not integers. But some rational numbers are integers. Okay, this is how they can ask questions. Well, they can ask question like that. Whether all the natural numbers are integers? Yes. Whether all the integers are rational numbers? Yes. Whether all the rational numbers are natural numbers? No. But some rational numbers are natural numbers. So this is one of the point where they can ask questions. And next, the properties. They will ask whether the rational numbers are closure under addition, multiplication, commutative, associative, distributive. They can ask. And the operations: addition, subtraction, multiplication, division. Okay, addition means we have to first make the denominators equal and we have to perform the addition. Subtraction also similar. Multiplication, no need to make any changes. Multiply the numerators, multiply the denominators. Okay, to find the division, okay, first number you can keep it constant. Second number you reciprocate it and multiply. Okay, reciprocate it and multiply. You will get some value which is known as division. Okay, so this is how to perform the operations. And next we have discussed about the identities. Additive identity, multiplicative identity. Additive identity is 0, multiplicative identity 1. What is additive identity? Any number, when it is added with the additive identity, it will provide the result as the same value. Okay, when it's multiplied with 1, it will provide the same value. So they can ask, write the additive inverse of 2. Then what is the answer? Minus 2. Additive inverse of minus 1, 1. And they can ask a question, write a number which additive inverse is also equal as the number. The number and its additive inverse are equal. The answer will be 0. So 0 and 0 and the additive inverse of 0 is also 0 only. So 0 plus 0 will give 0 and 0 into 0 will give 0. And 0 is the only number whose additive inverse is also the same as the number. Okay, they can ask 2 by 3. What is the additive inverse? Minus 2 by 3. So they can ask, what is the reciprocal of 2 by 3? 3 by 2. They can simply ask 2 by 3 into some value will give answer as 1. And the value will be reciprocal of 2 by 3. So whether the answer is true or false, true. So like this, they can ask some logical questions. So if you know the concept properly, you can answer. And to represent number lines. And one of the most important question is, how many rational numbers between two rational numbers? Infinite. There is no specific value. Many numbers is possible. And we have proved it also in this class. Okay. And to represent in a number line, write the positive values and negative values as per the question. And divide it by the denominator and mark the values. Okay. In this way, this chapter ends. And this chapter is an easy chapter. And you can work out on the exercises. Any doubt, we can post it in the comment box so that I can answer to it. Like, share, subscribe my channel.